Good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 34 is on the screen. Let's get started, please. Notice I took away a couple of things and I left some others there, and I'm bringing back something that we already covered. Hopefully you can remember from there. And I'm just adding for that number 4, the graphing portion. Just if you notice, I've been adding little things by little, just to bring it back. Give you some time for that. Copy and go. All right. So here goes number 1, just to recap where we've been. At the beginning of the school year, we did a full review of Algebra 1. This should have been, oh, no, that's not yours, sorry. There it is. This should have been fresh in your memory, in case you forgot. There's 2 ways of doing this. The first one, you multiply the entire equation by the common denominator. Is that correct? That's one way. The second way is that there's a fraction equal to another fraction. Who remembers to do what? Yeah, cross multiply. So here we go. Whenever you have a fraction equal to another fraction, cross multiply. I start with the x. So let's see. What is 3 times x? 3x equals, what is 2 times 12? That's 24. And the rest is history. We solve. Divide by 3, divide by 3. X equals to 8. My brain's going faster than me. X equals 8. Hands if you got that. All right. Like I said, there's 2 different ways. The other way, you could have multiplied the entire equation by 6. Distribute to the numerators. The denominators would be times 1 and simplify. Number 2, factors. Negative 4 on top. Negative 3 down here. All right. So what are the factors for number 2? Tell your neighbor, please, what you get for factors of number 2, and then we'll have Brandon help us with this one. All right. Brandon, Felix, factors for number 2. 1 and negative 4. Hands if you got those 2 numbers. All right. And the shortcut, if this one doesn't have a leading coefficient, we just do x and x. The first number is positive 1. The second number is negative 4. Hands if you got that. All right. We got it. Number 3. GCF is what? 3. We're left with x squared minus 1. Tell your neighbor what this becomes. What's inside of the parentheses. What does that become, please? Share with your neighbor, please. Then we'll have Maya help us out. This one, red flag the square and the minus. So that becomes what, Maya A? Yeah, x minus 1, x plus 1. And just bring down the 3. Hands if you got that. That is correct. Number 4. I'm going to solve for y. Line down the equal sign, plus 9x plus 9x. We got 3y equals 9x minus 12. Divide by 3. So we got y equals 3x minus 12. Hands if you got that. All right. I'm going to get my table going. X, y. For my x values, I'm going to use negative 1, 0, and 1. And for my y values, I'm going to substitute this in here. Yes? Oh, yeah, I did that on purpose, see if you guys were paying attention. 12 divided by 3, that's negative 4. Watch. Check this out. Let's go. Let's go. I got this. So, negative 1 times 3 is negative 3 minus 4. That's what? Negative 7. Yes. Next value. 3 times 0 is 0. That leaves us with negative 4. Next one. 1 times 3 is 3 minus 4. That's negative 1. All right. So with that said, let's graph this. Create a little coordinate plane on the side. This is our x-axis or domain. This is our y-axis or range. And of course, in the center is what? 0, 0. So, negative 1 of x, negative 7 of y. Negative 1 of x is right here. Negative 1. Negative 7. 1, 2, 3, 4, 5, 6, 7. So that point is right there. Next one. 0, negative 4. 0, negative 1, 2, 3, 4. And last one, 1, negative 1. 1, negative 1. It's about right there. Once we have our points, we graph our line. Bless you. Nice and straight like me. Look at that. Beautiful. Tamika's shirt, right? Q merch, right? $10, bam. That money, let's go. All right, we good? All right, send me your warm-up, please, on Nearpod, and then copy the agenda right after that. Agenda warm-up number 34. Today we're moving on to subtracting rational expressions, and tonight's home play, only 6 problems, only. Now, hopefully with yesterday's practice here in class and then you by yourself at home with addition, I think we can move on. Assume that we can move on, yes? Yes, thank you. All right, good. And thank you for those of you that were that came in during advisory to take your pop parte, those of you that were absent. Appreciate it. All right. All right, copy the code for tonight's home play. 6YFVT. 6YFVT. That should give you access to the Nearpod presentation, and in there's going to be the home play. However, last night you had a home play, and notice that at the end of the home play or the PDF, there was the answers. Is that correct? Yeah, so that was for you to check your work. So go ahead and go to Canvas, turn that in, please. It was for addition of rational expressions, extra practice. Tonight's is on the screen. There it is. It's only 6 problems. All right, and then get a Cornell note ready, please. I'll wait for you. Go. Our objective for today, I can add and subtract rational expressions. I can add and subtract rational expressions. We already covered addition. I left you a video sesh the other day. We spent yesterday doing some practice on it. Today we're going to add the second part, which is subtraction. Hopefully we got it, yes? However, before we move on, and without looking at your notes, remind your neighbor, what would be a definition in your own words for rational expressions? Definition in your own words for rational expressions. Tell your neighbor, please. Definition in your own words without looking at your notes. All right. Let's see. Type me something on your screen. Definition for rational expressions. In your own words. It doesn't have to be exactly what it was before. Think about it. Rational expressions. You have to type something. Think about it. They drop you off up on top of a mountain. They tell you the only way to get down from here is if you come up with a definition. Oh, and by the way, you want to poop. There's no restrooms up there, so there you go. Yeah, think about it. You got to get off. So, definition in your own words. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time. Here's one from your colleagues on your screen. They wrote, numerator and denominator are polynomials. Would you take that definition? Yes. Numerator, denominator, polynomials. What would be another one? How about fractions with polynomials? Ooh, yes. All right. So, yeah, algebraic expressions, numerator, denominator, polynomials. We have that already. From there, I gave you guys an introduction to the definition for quotient or fractions, right, Anthony? Yeah? All right, good. From there, you took notes on the steps to follow for addition. Is that correct? This is the same process for subtraction. So, y'all ready? Yes, Mr. Q, bring it! Okay, copy number Q, example Q, negative g over 2g minus 3 minus negative 3 over 4g minus 6. Copy that, please, and then we'll do the whole thing together. Yeah, I think they like me there, so. All right, y'all ready? Here we go. Step 1, it says, factor the denominators completely and find the common denominator. So let's go with the first denominator. I'm going to do that in green. Can I factor the first denominator anymore? No, that stays the same. How about the second one? Look at it. Can I factor that? Yes. What would be my GCF? 2. All right, and that leaves us with 2g minus 3. All right. So, with that said, check this out. Question. What does the first denominator need that the second denominator has? The 2, right? So that means we need to multiply this times 2 and the numerator times 2. So, our common denominator is 2 times 2g minus 3, 2 times 2g minus 3. So step 1, we got it. Step 2, rewrite the fraction for addition and subtraction. So we're going to step 2. There we go. What is 2 times negative g? Negative 2g. You're like, Mr. Q, this seems like addition. Yeah, the only thing here, look up to the screen, here goes the most important spot, that for subtraction, you need to distribute that to anything on the numerator to the right. Let me repeat that again. That negative has to be distributed to anything on the numerator to the right. So if this had more terms, we distribute the negative to all the terms. That make sense? Make a note right here, asterisk, heart, then just write distribute to numerator on right. All right, here we go. What is negative times negative 3? Negative times a negative? Positive, so that is a 3, and I'm going to change this to a plus. All right, we're still adding, so now these two become one fraction. Common denominator 2, 2g minus 3, and then we focus on the numerators. We have 2g plus 3. Can we combine? No, they stay as is. Negative 2g plus 3. All right. So we're done with step 1, step 2. Step 3 says simplify. What does that mean? Identify giant 1. So that means we need to factor one more time. Look at the numerator. Is there a GCF for the numerator? No, but since we have a negative here, I'm going to factor a negative 1 out. So remember that. Anytime there's a leading coefficient of a negative, make sure you factor that out. So that leaves us with 2g. 3 divided by negative 1 is negative 3. Bring the denominator over to 2g minus 3. Do you see the giant 1? Yes, tell your neighbor the giant 1, please. What's our giant 1? Andrew, which one? Yeah, the 2g minus 3 is the giant 1. So that leaves us with negative 1/2. Negative 1/2. Now, at the end, they want us to find the excluded value. So make a note here again. No, this is a heart. No EV. And tell your neighbor, look at the denominator. Why won't we have an excluded value? Talk to your neighbor, and then Anthony D will enlighten us. Look at the denominator and tell your neighbor why we won't have an excluded value. All right, Anthony D, why not? There's no variable, so make a note here in parentheses. No variable. Anytime that you have a denominator without a variable, there is no excluded value. All right, so what's the difference from addition to subtraction? That we need to distribute what? That negative to the numerator. All right? So with that said, give me a second. Send me your notes, please. Then copy that one on the screen. Example omega q, x over x plus 7, x minus 7, minus 7 over x plus 7, x minus 7. Copy that. Let's do this one together. X over x plus 7 times x minus 7, minus 7 over x plus 7, x minus 7. Step 1, it says factor the denominators completely. Who notices that they're already factored? Yes? Okay. And what do you guys notice second? That they are what? The same. Okay, so we can move on from here. So, let's see, step 1, let me use my handy dandy tool here. Step 1 is done. Step 2, rewrite each fraction. We don't have to because it's already the same denominator. But now we have to add and subtract. We're still on step 2, so let's do add and subtract. So we write this as 1 denominator, x plus 7, x minus 7. All right. Focus on the numerators. So tell your neighbor what to do at that point, and what do we write there? What do we write there? All right, what do I do, Courtney Jean? Write x minus 7, or once again, don't forget to distribute this over here. That makes it a negative 7, yes? So it would be x and negative 7. There it is. All right? Bye now. You said this. All right. Next. Giant 1s. Well, first, look up. Do you see the giant 1 right here? But just to be clear, what would be a GCF for the numerator just so that we can actually see it? A what? A 1. So I can rewrite this one as 1 times x minus 7. That's my numerator. My denominator stays as x plus 7, x minus 7. And now you can actually see the giant 1. About to now, and that leaves us with 1 over x plus 7. All right. Are we done? Pretty much yes. However, I'm asking you to compute or to find me the excluded value. Tell your neighbor what to write for the excluded value, how to get started. And then Kimberly will enlighten us with the excluded value. All right. What do I write, Kimberly? X plus 7 equal to 0. She said negative 7, but I just want to make sure everybody understands where we get that from. Take the denominator equal to 0, minus 7, x equals negative 7. From 1 to 5, I'll come to borrow you with these. Yeah, 5, 5, 4. Okay, we got it. All right, send me your notes, please. Oh, sorry. There you go. Example 1, we have x plus 5 over x squared minus 9 minus negative 2x minus 4 over x squared minus 9. Copy that, please. We're also going to do this one together to make sure we got it. Some of you can go ahead if you want to go ahead from there. Here we go. Step 1, factor the denominator. So, look at the denominators. Tell your neighbor what factors we write for x squared minus 9. What factors do we write for x squared minus 9? Tell your neighbor, please. What are my factors? All right. Looks like Selena's got it. Very good, Selena. Factors, what are they? X plus 3, x minus 3. Look at that from the corner. X plus 3, x minus 3. So what do you guys notice? That they are the same, yes? So I'm going to bring those down so I can rewrite my two fractions with those denominators. X plus 3, x minus 3, x plus 3, x minus 3. So the first numerator, is there anything multiplying this? No, so I just rewrite it, x plus 5. However, tell your neighbor what to write for the second numerator. Tell your neighbor what to write for the second numerator. Second numerator, what do we write? Jaden, go. Yeah, since we have the common denominators, we don't need to multiply times anything on the side. However, GCF would be what? Okay, so for right now, let's rewrite it, and then we'll do the simplification later. So, what would I write? Yes, 2x plus 4. That is correct. Remind your neighbor why, please. Why did that become 2x plus 4? Because we needed to distribute the what? The negative to both terms. Change that to an addition. Therefore, now we're down to one fraction, parentheses x plus 3, x minus 3. Combine like terms. Brianna, what would I write on the numerator? (3x plus 9). Hands if you got that. Now we do the GCF on the numerator. Jaden, GCF? 3, and that leaves us with x plus 3. Denominator stays the same. X plus 3, x minus 3. Do you guys see the giant 1? Yes, is it cute? Answer, 3 over x minus 3. Almost done. Find me the excluded value. And then send me your notes, please. So I'm going to send you the screen. What'd you get for your excluded value? Rebecca. 3. Hands if you got 3. All right, so far so good. Copy this next one. Example 1Q. Negative x minus 7 over x squared minus 25 minus negative 2x minus 2 over x squared minus 25. I'll give you guys some time for this one. You should be able to do this one completely. It's very similar to the one we just did. If you have questions, just ask Anthony E. He's got it. Go. All right. Let's see. First thing you did, Laura, what'd you do first? the x squared you square rooted? Yeah, and then you got what for each denominator? X minus 5, x plus 5 for denominators. Hands if you got that in any order? Yes? All right. From there, we rewrite each fraction with that denominator. X minus 5, x plus 5. X minus 5, x plus 5. Since we didn't multiply the numerators by anything, the first numerator stays the same, so negative x minus 7. So far so good, yes? However, what did you write for the second numerator? Pass it to someone, Laura. Courtney Jean, what did you write on your second numerator? 2x plus 2. Hands if you got that. That is correct. So when we distribute the negative, we put a plus there, and this changes to its opposite. That is correct. From there, we write one fraction, x minus 5, x plus 5, and then we combine like terms for the numerators. So 2x minus 1x, that is x. Negative 7 plus 2, that is negative 5. Hands if you got that so far. All right. From there, what did you write for the GCF on the numerator, everyone? 1, and you left it as x minus 5, denominator x minus 5, x plus 5, and the rest is history because the giant 1 is here. Answer, 1 over x plus 5. From 1 to 5, I'll come to borrow you with this. Yeah, 5 fourths, okay. And of course, you wrote your excluded value. Excluded value, everyone? Negative 5. All right. Ooh, let's go. You guys remind me of me in kindergarten. Let's go. Copy this one, please. Example 2. 3 over x minus 5 minus 1 over x squared minus 7x plus 10. 3 over x minus 5 minus 1 over x squared minus 7x plus 10. Three over x minus 5 minus 1 over x squared minus 7x plus 10. So the first step is to factor the denominators. Can we factor the first denominator? Nope. How about the second denominator? We can factor it. So 10, and down here the negative 7. Tell your neighbor two numbers that when you multiply them give us 10, and when you combine them give us negative 7. Two numbers when you multiply and give us 10, positive 10. When you combine them, give us negative 7. Sorry. What are those numbers? Don? Negative 2 and negative 5. Hands if you agree with that. Yeah, so my factors for this denominator are x minus 2 and x minus 5. Okay, so look at it. The second denominator has these two. The first denominator only has that. What's missing on the first denominator, people? So we put in parentheses x minus 2, top and bottom. And now we can write our two fractions with a common denominator. Common denominator x minus 2, x minus 5, x minus 2, x minus 5. So the first numerator, we have to distribute that 3, is that correct? So 3 times x, 3 times negative 2, that is what? 3x minus 6. Tell your neighbor what to write on the second numerator. Tell your neighbor what to write on the second numerator. What do we write on the second numerator? What do we write on the second numerator? Jacob. You said negative 1. You said don't forget to distribute this negative there. That is correct. So that means we put a plus right there. Okay, hands if you got that? All right. Therefore, now we have one fraction, x minus 2, x minus 5, and then we combine the numerators. All right, tell your neighbor what to write on the new numerator. What to write on the new numerator. Shade it. Go. Minus 7. Hands, have you got that? Can we factor the numerator again? Just 1. However, if we do that, are we going to have any giant ones? No, so then we're done. However, excluded value. Tell your neighbor what to write to begin finding our excluded value. What do we write? Then Ryland's going to enlighten us. Ryland, yeah? He said x minus 2 times x minus 5 equals 0, and then set each one equal to 0. That is correct. And solve. So plus 2, x equals 2, plus 5, x equals 5. Excluded values are 2 and 5. All right? So, send me your notes, please. All right, and the last one, example number 4. 3x over x squared minus x minus 6 minus 5 over x squared minus 8x plus 15. It's going to be a long one, so make sure you have plenty of space. Yes, Mr. Q. All right, good. Story of my life. You should do like a mathematician voice, right? All the math teachers singing, right? You guys are the judges. What do you guys think? Yeah? I don't know if you want to hear that. All right, now that you copied it, tell your neighbor the very first thing you're going to do. What's the first thing you do? First thing to do. First thing. Yeah, factor the denominators. So, start with the first denominator. -6, -1. So, what two numbers multiply give me -6 that when you combine them give us -1? Tell your neighbor, what two numbers multiply give me -6 that when you combine them give us -1? Two numbers. Give us those numbers. Martin, what are those numbers? He said -3 and 2. -3 and 2. -3 times 2 is -6. -3 plus 2 is -1. So my factors for this one are x minus 3, x plus 2. All right. I want you to find me the two factors for the other denominator. Find them, please. Factors for the other denominator. Two numbers that multiply give me +15. That when you combine them give us -8. Tell your neighbor the two numbers that when you multiply them give us +15. When you add them give us -8. All right. What are those numbers, Jaylene? -3, -5. Hands, have you got that? Yes, so our factors are x minus 3, x minus 5. Okay. Question. What does the first denominator have that the second denominator needs? Look at it, guys. What does this one have that this one needs? X plus 2. We do that times numerator and denominator. So, with that same idea, what does the second denominator have now that the first one needs? x minus 5. Is that correct? So we multiply the numerator times x minus 5. So our denominators, now we have a long denominator for each. We got x minus 5, x minus 3, x plus 2, x minus 5, x minus 3, x plus 2. So let's go to the numerators. The first one, we multiply 3x times both terms, so that gives us 3x squared, and 3x times negative 5 is negative 15x. Okay. So be careful with the second one, though. Tell your neighbor what you're going to distribute into the red parentheses. What do we distribute to the red parentheses? Tell your neighbor, please. What do we distribute? All right. Brandon, Darty, what do we distribute? The negative and the 5. Yes, the negative and the 5. So distribute that here and here. That gives us negative 5x minus 10. Change this to addition. If you didn't do that, bless you. Make sure you put a note here for yourself. Bless you. All right. Now we have one denominator. Combine them. We got x minus 5, x minus 3, x plus 2. And then we're going to combine like terms on the numerator. All right. So, do we have any other x squares? No. Bring that over. 3x squared. What is negative 15x and negative 5x? Negative 20x. And what, we just bring the negative 10 over. Okay. And we'll stop right there. Yeah? All right, guys, reminder, tutoring after school. Your home play, make sure you do those 6 problems, because tomorrow's Friday. Remind your neighbor what's up with tomorrow. Let's go. Let's go. Oh, yeah. Some of you are like, there's a football game, Mr. Q. Oh, okay. Gotcha. Later, guys. Have a good one. See you guys tomorrow. Bye.